productivity and the customer value in the construction industry, as there exists the potential in the productivity in the construction industry. We look into the car industry, which is quite different from the construction industry. Tesla came into the market a few years ago, and they disrupted the market by coming in with electrical cars. Even though they are not profitable as their competitors, the stock value has increased quite substantially over time. This has driven the competitors to develop products similar to Tesla as a fast follower. This disruptive behavior can also happen within the construction industry, as well as driven by the increased efficiency. This is a topic of today's seminar, and if you have any questions during the seminar, the chat is open and we will answer your questions as we go along or answer them afterwards. So we'll take a topic at the end with the questions that you have posted. In this seminar, we will have Tobias to talk from model management, has worked 15 years advising companies in many different companies types, such as telecom and construction industry and other areas. And we also have Måns, who is also a consultant with model management, who is working mainly with modularization and configuration in the industry and has worked with some of the customers within the construction industry. I will hereby then invite Tobias to talk. Welcome, Tobias.
Thank you, Magnus. So the title of this webinar is 3 steps on how to improve productivity and customer value in the construction industry. And this title comes with the implication that the productivity and customer value actually needs improvement. So that is, of course, something that can be said to always be true in all businesses. So let's have a look at some of the reality of today. In comparison to other industries, one could argue that the productivity of the construction industry has not seen the same development over the past decade. Within the EU, we can see that the construction industry has been struggling to grow and has just recently reached the level seen a decade ago. At the same time, other industries are seeing growth in a much more stable fashion. But is this a fair comparison? Are we comparing apples to apples? Aren't different industries affected in different ways by the turns of economy? The information and communication sector that stands out in this chart is obviously very different. New products and services are constantly seeing the light of day, innovations that truly change the way we live our lives. And comparing to manufacturing is also somewhat misleading, because manufacturing typically has the same product to be manufactured over and over again by the same production system. And this leads to what can be argued as one of the most important factors in industrial development, continuous improvements. A concept where small incremental improvements are stacked on top of each other, a continuous evolution that when viewed in the rear view mirror looks like a revolution. But industries is just one way to divide the world. Another divider that often describes the reality I see better every day is project-based and product-based. In the project-based industry, the project is what is essentially delivered to the customer. It's a typical way of operating for low volume, low repetition, heavily customized and often very expensive products. In the product-based industry, on the other hand, the product is what is sold, and all the development goes into the product, often without even knowing who the actual end customer is, and very often with a series of products produced of the same variant. The well-documented product and the stable process to produce it are extremely important assets of any product-based company. Products have strategic plans and they are continuously maintained and improved, which typically leads to continuous productivity and customer value improvement. In the project-based industry, on the other hand, each project is typically responsible for developing the product to produce, more or less from scratch. And this might be necessary if the highest degree of flexibility is needed. However, as soon as we limit the scope of the product a little, we can often find items that are repeating on some level. Perhaps not on the whole product level, but on lower levels, we can find solutions that could be configured to the needs of the unique customer. And these are items that we could put into a construction system. Let me illustrate. In the project-based scenario, each project has access to the complete breadth of available solutions on the market, evaluating and selecting solutions regarding both the product and the process. The focus is on project profitability, and this is often ensured both through organization, incentives, and culture. Efficiency is of course in focus, but gains are only realized inside the project and not on the whole portfolio. In the configuration-based scenario, each project utilizes a central construction system. And the central construction system is designed with access to the complete breadth of available solutions on the market. A central function evaluates and selects solutions. Product and process is configured from the prepared solutions, and it is centrally decided which solution to use for which case. Focus is on long-term bottom line profitability. Efficiency improvements are fed back to the construction system and reused across the portfolio of projects. But will this not limit us? But let's discuss what a construction system is, and especially what we need to consider to have a good construction system. First, we must define what a construction system is. And we like to define it as three things. First, having prepared solutions to meet the scope of the construction system. Two, having documented the solutions in a way that they can be applied repeatedly. And three, continuously improving the construction system regarding its design, production, and documentation. But by this definition, many solutions will actually qualify as building systems. So how would we know if the construction system is good or not? There are two fundamental drivers for the value of using a construction system. First, that it is flexible so that it can satisfy the need of many different customers, and this will enable a larger sales volume. Second, we wanted to satisfy the need for a long period of time, because this would enable volumes to consolidate year over year. And increasing the length of life not only allows for a longer lifetime and longer time for investment payback, but also for a longer time of continuous improvement. Again, one of the most important factors for industrial success. While reducing the scope of the construction system will make it easier to standardize on technical solutions, it will also decrease the number of cases where the system can be successfully used. And in all industrial operations, consolidation of volumes is a prerequisite for efficiency. But if we devalue the product to reach this, we are in big danger. This has been observed many times in history when it has been obvious that the main difference between a premium and a lower priced product is the label on it. The challenge here is to make a system that is configurable in such a way that the system can have a very wide scope in customer value fulfillment without sacrificing efficiency in that specific case, and to allow for development of parts of the system without starting over, to enable necessary development over time, but in a controlled way. I'm sure that the audience of this webinar have thought quite a lot about construction systems, but as you all know, many of your colleagues immediately think of prefab when you mention construction systems. That is of course not wrong. But what I would like to argue is that there's a lot more to a construction system than prefab. But let me take a moment to discuss prefab. The fundamental equation of prefab is the vision that factory production inspired by, for example, the car industry or the home appliance industry has a much higher productivity due to specialization and more efficient material flows, and also lower labor costs due to lower skill requirements. The controlled environment inside the factory promises higher and more even quality and an improved work environment. However, seeing prefab in the construction industry, there are some shortcomings that are quite easily observed. First, many prefab operations are actually far from as industrialized as the car industry in reality, even though they have the controlled environment of the factory. Many prefab suppliers tend to understand the value of their product, meaning that the actual construction company doesn't win the complete financial benefit of the change. Prefab introduces a transport of items, and these items have a higher degree of finish, meaning that they are more sensitive to the surrounding conditions, both during transport and on the construction site. Volume elements may introduce a rigidity in the floor planning for the architect, meaning less efficient use of space. And a higher degree of finish may decrease the possible variance offered to the customer. As an example, look at prefab bathrooms. They are assembled before the apartment is even sold in many cases. That means that logically, you can't sell a customization of the interior of that bathroom, and the value of that possible customization is lost. So all in all, we must realize that prefab is not the one solution for the productivity problem. It may be a part of the solution, but it will always have the strongest effect when we over time can optimize the setup for different parts of a construction system. So let me explain what I mean. I will try to relate construction systems and prefab by sketching a simple framework. Having prepared and documented solutions that we continuously improve are the fundamentals of a construction system. But preparation is of course a scale, and being prepared is a quite vague word. A construction system does not necessarily mean that we have all the Lego bricks in a warehouse ready to be assembled. I would argue that the first step of introducing a construction system is deciding what solutions do we use for each function. We could, for example, decide that we use precast concrete slabs, but more important than defining all the possible sizes of these elements is perhaps to decide the height of the slab and how it connects to other parts of the building. In the definition of a construction system, we must also understand that it's not necessarily that we must select only one solution for each function. It's more important to document why and when we need to have different solutions. Perhaps we want to use a wooden slab for buildings lower than 4 floors, but a concrete one for taller buildings. This could be driven by both internal and external stakeholders. This is perfectly fine. The focus should be on standardizing the interfaces again, as far as possible, to not let this needed variant spread to other parts of the buildings. Perhaps we could use the same stairs, elevators, shafts, etc. It's also perfectly fine for different parts of the construction system to be on different levels of preparation, as long as we have selected the system concepts across the system. For example, the bathrooms could be fully designed, ready to configure, while the roofing just has the concept selected and must be detailed in every project. What's important is to start something that can be continuously evaluated and improved. In the other direction of this framework, we put a level of prefabrication, all the way from complete on-site construction to finished rooms or even buildings transported to and assembled on site. Traditional construction is when we're working project by project with on-site construction. Prefab construction is when we're working with prefab, but still project by project. Above the middle horizontal line, we're working with construction systems, And the further to the left we go, the more flexibility we have to adapt the process for late customizations or other project unique differentiation. And the further to the right we go, the more benefit we can draw from the promise of prefab. Different parts of the construction system can be positioned at different levels of prefab, depending on the need for flexibility or the benefit prefab gives for that specific part. I have now explained the need of moving from project-based to configuration-based construction. I have defined what a construction system is and what aspects are essential for a good construction system. I have also related construction systems to prefab, but as you all know, it's not a simple task to move from project-based to configuration-based construction. It takes a big effort to design a construction system that takes the wide scope of customer needs into account. And as I think you all know, designing the construction system is the easy part. Changing the ways of working and the culture is much harder. And on top of that, perhaps you must invest in and implement new digital solutions to realize all the potential benefits. Måns will tell you a bit more about how to get there.
Thank you, Tobias. We'll now go on to present the 3 steps that we have identified as crucial to face the challenges in the construction industry. I will start to talk about configuration system design and the importance of using market demands and the strategy of your organization as input when creating a construction system. I will also give some examples of how we can achieve a construction system that is both flexible and efficient. We'll then go on to look at how the processes and organization has to change when we want to work with the continuous improvement, and what is the role of the project and how can we improve the overall performance of the organization rather than sub-optimizing each project. Finally, I will talk about the importance of information management and digitalization and what it really means from a construction system perspective. Tobias mentioned 3 things that define how we should work with the construction system, and they correspond to the 3 steps that I will talk about. And having a prepared solution obviously relate to the construction system design. So what does it mean to have a construction system that is prepared? Well, as mentioned, it all starts with the customer. Fulfilling your customers' needs will secure your price premium and market share, hopefully both. But there isn't one solution that fits all. The construction system has to be flexible enough so that it could fulfill the need of your target segments. Let's look at an example that the customers might value when buying an apartment. Some might put storage as one of the more important criteria for selecting a new apartment. And they will filter out all apartments that they look at that doesn't have sufficient storage capabilities. Other customers could be pushed into making that purchase decision based on whether the apartment has a sustainability certification. And some will gain interest if are ensured that there's proper soundproofing between the apartments. Past experience made them aware how noisy neighbors can ruin an otherwise perfect home. And of course, the kitchen is important to many people and they want it to match their taste in design. So these are just examples, and in reality, you'll have many different customer values that in combination, they will make up need-based segments. And there's probably people already in the organization that have a good view of what your customers want, but they need to be translated into technical specification to make them useful for when designing a construction system that is prepared for the market demands. So by connecting the customer values and their importance to a construction system requirements, you'll get the construction system specification. This mapping will give you a good idea of what your product and how your product will directly affect your customer experience and how you can ensure that the construction system is prepared to meet your customers' demands. But the construction system also has to be prepared for your processes. So let's take the ventilation system of a building as an example. You have chosen to prefabricate the ventilation shaft in a factory. And for the design phase of a construction project, it will be important that it's easy to pick the right air duct shaft and that it doesn't have to be redesigned for every project. It should also be easy to transport. If the air duct shaft is prefabricated, they need to be able to fit on a truck and you have to handle them on the construction site. When the shaft is installed, it might be unprotected from rain, so it's important that it's designed so that it withstands weather, so that rain isn't collected in the ventilation system. And same as with the customer values, they have to be translated into construction system requirements so that it's clear what that actually means when you're designing the construction system. I will show this visualization to put the market input and process input into relation with each other. And it also relates to what Tobias talked about regarding having a flexible and an efficient construction system. This graph describes 3 dimensions that represent different strategic directions that a company can take. Operational excellence means that you try to cut costs and create an even quality by standardizing processes. That's the top axis. Customer intimacy means that you are really good at meeting your customer demands and you'll be able to present the customer with a solution that fits their specific needs. And finally, we have the product leadership axis, and that means that you have the best performing product on the market. So if you increase the operational excellence, you'll get cost reduction, increase the customer intimacy to increase market share, and increase product leadership to increase your price premium. And traditionally, these strategic directions has been seen as incompatible. But if you have a smart construction system that is modular, you can fulfill all these strategic directions in the same product. So by letting the customer design their kitchen interior, you will fulfill their specific needs. But this will speak against having the kitchen prefabricated and shipped to the construction site, since that will increase the lead time and not allow for late customization. Maybe you can prefabricate and pre-assemble the kitchen cabinets, but the kitchen doors on the cabinets are visible to the customer and can be assembled on site just before the customer moves in to allow for late customization by the customer. And the heat recovery system might be something that you want to put research and investment into. Having the best heat recovery system on the market will reduce heating cost for the customer. And if you go for this strategic direction, it's important that you prepared for that technological development. So if the heat recovery system is expected to change, you have to make sure that there's space for that new heat recovery unit and that you protect other parts of the construction system from change just because you change the heat recovery system. So the heat recovery system also connects to the ventilation system. And in this example, you want to keep that the same over time. So then it's important that you have an interface to that prefabricated ventilation shaft to protect the design of the ventilation shaft, to be able to work with continuous improvement for cost reduction, which is here represented by the operational excellence axis. And you're then able to take these long-term investments and harvest the long-term benefits. And again, it's important that you protect this part of the construction system from changing occurring in other parts of the system. So you will allow every customer to have their specific kitchen cabinet doors, which is also part of the construction system, but assembled on site to allow for late customization. And the construction system is also prepared for introducing a new heat recovery system, as that is the focus for constant development and improvement. And then you have the air duct shafts, which are prefabricated in huge volumes with low variance to optimize cost. That was the first part, and now let's move on to look at the processes and organization. This connects to the second thing that Tobias mentioned on how to work with the construction system, continuous improvement. And this is one of the cornerstones of industrialization, and I will put it into the perspective of the construction industry. So continuous improvement of processes have been attempted within the industry for long, but there are a few challenges related to how the typical construction company is organized. And of course, I'm talking about the project-based companies in many different industries are challenged by poor knowledge transfer, little reuse, sub-optimization of project profitability rather than the overall profitability, just to mention a few. This is because, of course, the project is, well, temporary. How can we work with continuous improvement when the organization at large is created and dissolved over and over again? Continuous improvement takes long-term commitment and investment. So the project will only see the cost right now, right? So, in any given construction company, there's not one ongoing project at a time. There's several, and often the same type of activities are done over and over in different projects. Apartments are designed and structural strength is calculated, suppliers are selected and subcontractors are acquired, and the individual projects are not prepared to take that cost to improve for the future projects. They're more focused on making their own project profitable. And traditionally, each project has been executed more or less as its own organization over and over again. And the only continuous improvement would be from people gaining experience from one project to the next. But of course, these days, we do have central organizational functions to support the project. This gathers resources together, and they do have the opportunity to work on continuous improvement because their organization is, unlike the project, not temporary. What we do see, however, is that there's not so much to bind the projects together. So the central functions will work to serve the individual project rather than taking a portfolio perspective that stretches beyond the boundary of the project. And this is understandable if the project has its own design, suppliers, and subcontractors. But if we have a construction system that is used, then we can have that commonality in between projects. So with that construction system that is based on the customer segments and the project process input that we saw before, all projects can work from the same premise, and we will start to see a reuse between projects without losing that flexibility that they need. And this will give a structure and a commonality that makes it easier for central functions to then work with continuous improvement from a cost, quality, and value add perspective. This will require, however, that you work with product planning from a construction system perspective. You don't plan each individual project. You plan how to make the design and manufacturing of, let's say, the ventilation shaft for all projects as profitable as possible over a 3, 4, 5-year period. And that's how you get change. As the market, industry, and the organization changes over time, of course, you have to update the construction system, and that's why you need this planning and development function centrally working with that construction system. So the planning and development function of the construction system can be a unifying force for those other functions, having a cross-project view that is required if you work with a smart construction system, so that you get the volumes, logistics, sales, and the processes and manufacturing can be optimized for the benefit of the whole organization rather than each specific project. So yes, but it's not only about adding new processes, of course. You also have to look at the project's own processes, and they also have to change. And that's why it's very important, especially initially, to have central functions to support the utilization of the construction system in the projects. Unless the construction system is utilized, we don't see the benefits we expected. It has to be clear exactly how we realize the improvements in the project, what activities will be redundant, and how will we improve quality, how will the customer satisfaction increase, and so on. So this has to be continuously followed up. If this is not done correctly, we'll see a lot of the activities in the projects. Well, if it's followed up, we'll see a lot of those projects disappearing or being reduced. Okay. We now come to the third and final part, information management and digitalization, and this relates to what Tobias talked about, documentation. of the construction system, and the construction system has to be documented beyond what different parts it consists of. There has to be an underlying information model that connects the data and makes it useful for the projects. So a construction system is really a network of information varying from market data, technical specification, module variant specification, product structure, pricing, sales volumes, and so on. So people will need different information at different stages, and there is a need for a solid information model that stretches between projects and beyond the traditional BIM model. So the planning function of your organization, your engineers, your sales department, and so on will all need different information. They all have to be connected so that it makes sense in relation to each other. But let's look at the high-level example of how a digital setup could look. So first, you will need somewhere to storage the construction system data. This is where you describe all the building blocks, how they relate to your customer segments, what interfaces there are, configuration rules that describe how they can be combined. But this information also needs to be accessible for the different projects. And of course, it's possible then to have a construction system that is manually configured for each project. But there is also a great opportunity to digitalize this step, which of course then will reduce manual work, human error, and also reduce lead time. So for that, you will need a configurator to execute and configure the product depending on what the specific project need. So with the project interface, it's possible to give input of what the needs are, and the configurator will then look at the assortment and select the building blocks and prefab elements and component that is needed for that specific project. So together with the predefined construction system, this gives the potential to have huge savings in engineering and design and reducing that manual work. But next, there also have to be a receiving system for that configuration output, and here there's already a solution within the industry, the Building Information Model, BIM. Some industries talk about a digital twin. I would say the construction industry is already there to some degree. For each project, you do have a BIM model in many companies, and everyone involved in the project can access that same information from the model, and you all know about the benefits of having BIM. But here it also connects an information model on a higher level, so that it all goes together thanks to that construction system. And so thanks to that, they are connected to that higher level construction system. Central organizations can connect to the different BIM models for the different projects and do project follow-up and planning, etc. They can get volumes, progress, etc., etc. And this really enables for continuous improvement because the central functions will have real-time view of how the projects are progressing. There could also be a database for finished projects, and both to learn, but also to see a new business opportunity here. This is really a data goldmine. So I talked to Tobias before about an example where his father was working with heat exchangers before he retired, and they sold heat exchangers to a neighborhood, and they saved that information. 10 years later, they sent out an aimed offer, and they sold a whole lot of new heat exchangers to that neighborhood, and that's free money. So there's a huge opportunity here. We know when people want to change their system, they spend tens of thousands of euros on new kitchen renovations, and we should take some of that action in some way. And finally, I want to show that there is also an opportunity to digitalize the customer experience. So you can connect a customer interface to the configurator to get that input of what type of kitchen cabinet doors, let's say, the customer wants, and also get that digital thread to the BIM model. And that also gives us the opportunity to have a customer database, and altogether you'll get a customer digital experience that the customer nowadays expect. Okay, So I want to finish up by stretching this message. When digitalizing, what are the benefits we're trying to achieve and for who? It's all about someone wanting information. So let's say supply or sourcing, wanting better volume forecasting. Maybe it's for engineers that want to automate in what solutions they can pick for different fire prevention classes, or making it easier for the architects to select the right solution depending on what the customer segment you go for. Or of course you need to have the right information in production. But you could also connect your digital information outside your organization to your subcontractors. And of course, let's not forget about the customer to improve the customer experience. With that image, I'll give the word back to Tobias. Thank you very much for listening.
Well, thank you, Måns. Interesting stuff. I would try to summarize with a few key takeaways from this morning. So first of all, a construction system is prepared with solutions for its complete scope. It's documented to enable efficient reuse and governance. And it's continuously improved based on strategic product and process planning and feedback. And the value a construction system enables is increased customer value in product customization, technology leadership, and aftermarket services. It's increased productivity based on centralized documentation of experience, consolidation of volumes on modules for purchasing and prefab efficiency, and quality of information by system support and formal governance processes. And third, it's about increased speed throughout the whole development and construction process, boosting the working capital leverage. And the 3 steps to get there are: step 1, design the construction system based on customer values and process requirements. Step 2, enable the organization to centrally own and utilize the construction system with processes for reuse and continuous improvement. And step 3 is to digitalize the information management to enable increased speed and quality, increased customer value, and improved efficiency. So it was really great to have you this morning, and thank you for listening. And back to Magnus.
Thank you, Tobias, and thank you, Måns. It's been a great pleasure having you here, and I think we've given a good view on the digitalization and the impact of the construction industry. And to be remembered here as well, as going back to the car industry, if you look into the truck industry, those that are most profitable are those that are meeting the most customer needs and are most flexible. And I think this is something that you need to bring with you. If you have any questions or thoughts, please let us know. We will be contacting you and letting you have this video as you can go back to it. But we'll also take a chat with you and see how we can support you. Thank you very much for today, and thank you for joining us.